Good morning, students. My name is Mangalam Agarwal. In the previous class, I have solved a numerical based on the radial shear and the normal thrust, in which we have calculated the bending moment, normal thrust, radial shear at 2 meter from the left support. Now we are taking one more example of the various loading in which 2-point load and a UDL load is acting on the 3-hinge arch section. Okay, so let us see this figure. This is a 3-hinge arch A, B and the C. C is known as the crown and the rise of the arch is 5 meter. We have just calculated the resultant reaction, bending moment, normal thrust, radial shear at 5 meter from A support. Okay, that is A support, and we also calculate the maximum bending moment. So before solving this numerical, we just calculate the vertical reaction, that is VA and VB, and the horizontal thrust, and the resultant reaction, that is RA is equal to under root of, like Pythagoras theorem, VA square plus HA square, under root of VA square plus HA square for RA and RB. Okay, so for the calculation of VA and VB, we just take the moment at A is equal to 0. Okay, you can take the moment at B is equal to 0. Okay, I just take the moment at A is equal to 0. So VB multiplied by this whole distance 20 minus this vertical load 20 multiplied by 3 minus 30 multiplied by 3 plus 4, that is 7. Okay, and minus this for UDL case 25 multiplied by this 10 in the bracket half of distance 10 by 2 plus the remaining distance, that is 4 plus 3 plus 3, that is 10, like this. VB multiplied by 20 minus this 20 multiplied by 3 minus 30 multiplied by 7. Okay, minus 25 multiplied by 10 in the bracket this half of distance, that is 10 by 2 plus the remaining distance, that is 10. Okay, so we just calculate the vertical reaction at B support, that is 201 kilonewton. Okay, so the VA plus VB is equal to the total load, that is 20 plus 30 plus 25 multiplied by this 10. Okay, so VA is equal to 300 minus 201. 300 is the total load, that is VA is equal to 99 kilonewton. So now for the calculation of horizontal thrust at A and B support, the horizontal thrust, that is at A and B both are equal because they are equal in opposite direction. So HA is equal to HB. So I'm taking the moment at C is equal to 0, that is on ground on the right hand side. You can take the left hand side. So just like this, VB multiplied by 20 by 2, VB multiplied by 20 by 2, that is distance of half because I am taking the moment at C is equal to 0, minus 25 multiplied by 10 multiplied by half of distance, that is 10 by 2, minus this horizontal thrust HB into this vertical distance, that is 5, that is rise of arch. Okay, like this. VB multiplied by 10, that is 20 by 2, minus 25 multiplied by 10 multiplied by 10 by 2 and minus h into this vertical distance, that is 5 meter. Okay, so we just calculate here HB, and HA and HB both are equal, that is 152 kilonewton because they are equal in opposite direction. So now the resultant reaction is the under root of VA square plus HA square, and the RB is equal to VB square plus HB square. Okay, so we just calculate the first part here. So now we are calculate the bending moment, normal shear and the radial shear. So before proceeding this, we just calculate the bending moment at 5 meter from the A support. Okay, so we just calculate that what is the this vertical distance. We just note down that this point is D from the left support of 5 meter distance. Okay, so we know the formula here, y is equal to 4yc upon L square x into L minus x. 4yc is 5 meter, L square total distance is 20, x is 5 meter, and 20 minus 5, we just calculate y here, 3.75 meter. Okay, so bending moment at D is equal to VA multiplied by 5 minus 20 multiplied by this total distance is 5 meter, so 5 minus 3, that is, and h multiplied by this y is equal to 3.75, like this. Bending moment at D, VA multiplied by 5 VA multiply by 5, let this is the 5 meter, because till this is 4 meter, so let this be 5 meter. Okay, so VA multiply by 5 minus 20 multiply by 5 minus 3, and this horizontal thrust H multiply by this vertical distance, that is why we have calculated the 3.75 meter. So put these all values here, we just calculate the bending moment at D. So now for the normal thrust and the radial shear, we calculate the what is the slope between them. So dy upon dx, that is 4yc, or r is upon L square L minus 2x, that theta is the dy upon dx. Okay, and the r is the 5 meter. Okay, this is the 5 meter radius. So tan theta is equal to tan inverse of 4 multiplied by 5 upon 20 square in the bracket 20 minus 2 into 5. So theta is also calculated. So net vertical shear, I just already told you, VA minus 20, VA minus 20. Okay, so Rx is equal to, we know that this formula, V cos theta minus H sin theta, and for normal, V sin theta plus H cos theta. Put these all values here, we calculate. Okay, for the maximum bending moment, we consider the X distance from the B support. We consider the X distance from the B support. Let this is the X distance. Okay, so bending moment at XX, we calculate from the right support, because we consider the X distance from the right support. So VB multiplied by X minus W into X by 2 minus H multiplied by this, let be YX. Okay, so VB multiplied by X minus 25 multiplied by X multiplied by X by 2 minus HB multiplied by YX. Okay, this is the maximum bending moment equation. So we know the value of VB, we know the value of horizontal thrust. Okay, and we also know the value of YX. From where? From Yx can be calculated from this equation, 4yc upon L square x in the bracket L minus x. Okay, so yc is 5 meter, so 4 y upon L square 20 x into 20 minus x, and VB is equal to 201 kilonewton, W is equal to 25 kilonewton. So bending moment equation, after solving this, become this equation. Okay, so we just differentiate with respect to x and put equal to 0. So x is equal to 5 meter. So put the value of x is equal to 5 meter in bending moment equation, and we just calculate the maximum bending moment. Okay, so this is our numerical for the different loading cases, in which we calculate the resultant reaction bending moment, normal thrust, and the radial shear at D from 5 meter distance from the A, that is left support, and the maximum bending moment. Okay, this is very important, and in the next class I am telling you about the circular arches. Okay, so please be serious.